Okay, this is the first part of the paper 2. And the first question is all about the factor theorem and the remainder theorem. So I've got x minus 2 is a factor of that. Means that f of 2 is equal to 0. If you evaluate it, you get 8 plus 4a plus 2b minus 4 equals 0, which means that 4a plus 2b equals negative 4. That's the first equation. And the second equation, x minus 1, leaves a remainder of 6, means that f of 1 is equal to 6. So that gives you 1 cubed plus 1a plus 1b minus 4 equals 6. So you've got a plus b equals minus 6, so that's minus 3. And that gives me two equations. The red one, a plus b, is minus 3. And simplifying the blue one down, 2a plus b equals minus 2. So subtracting blue minus red, it was purple, I guess. Give me a equals minus 2 minus 3 is minus 2 minus minus 3 is 1. And then once you've got that, we know that 1 plus b is equal to minus 3, which means b is equal to minus 4. Done. Question 2. The first term of the common ratio of a geometric series are denoted by a and r. Given that and they're both rational, that does come into play later. Given that the third term is 9 and the sum to infinity is 64, find the value of a and the value of r. So I've got u3 equals a r squared, and I get s infinity equals a over 1 minus r, and u3 is equal to 9, so I've got ar squared is equal to 9, and I've got a over 1 minus r is equal to 64. I can divide one by the other and cancel the a's. It's another simultaneous equation. I can do 1 over 2. That gives me r squared. Okay, let's do ar squared divided by a over 1 minus r equals 9/64. I just tidy that up. Obviously the a's cancel, I get r squared over 1 over 1 minus r is 9/64. And you end up with a cubic equation, r squared 1 minus r equals 9 over 64. I'm going to rearrange that equal to 0. R cubed minus r squared minus 9/64 equals 0. And then evaluate that in your calculator, which I do by graphing it, but I know there are other ways. So y equals, in the calculator, x cubed minus x squared minus 9 over 64. I've typed that wrong, so I'm typing it again. Graph it. You get 3 answers because it's a cubic, potentially. And then just solve. Find the roots, and it gives you the answer that r is 0.75. Once you know that, it's easy to go back and plug in, or 3/4. That's me. So it's easy to plug in that a times 3/4 squared equals 9, and just do a divided by 3/4 squared will give you a is equal to 16. Okay, cumulative frequency. This is a nice easy one. Just reading off the graph. 1.1 is there, 1.2 there, and so on. We'll do a bit better than that. It's not so clear on the smart board, but you can probably on the paper version. In fact, everyone managed to get these. Read off these values. So just counting squares in between. Each square's worth 2. That's easy. To get the mean and the standard deviation, again, all you do is type it into your calculator. So in the stat menu, you can edit the lists. And you can fill in these two lists. Well, you fill in this, the midpoint here, so 1.05, 1.15, 1.25, 1.35. And on your calculator, you can tell it to give you estimates. Press the one variable statistics button. That will give you the estimates. So mu is 1.26 and sigma is 0.133, working to 3 significant figures. And then, so that's part B. And then part C, why is the normal distribution not a good model for this population? Well, because you can see from the graph that it's not symmetrical. If it was symmetrical, it looks something more like that. And you can see from these numbers that it's not symmetrical. 6, 28, 18, 14, 10. It's got a bulge somewhere near here, rather than peaking in the middle. So C, it's sufficient to say that the normal distribution is symmetrical. And this is not. This one was excluded, but I'm going to do it anyway, because I'm glutton for punishment like that. But also it helps you to refer back to later. So the modulus and argument of Z, given the argument in degrees, excuse me. Find the modulus and argument of Z given the argument in degrees. So that bit you should be able to do anyway. Mod Z is equal to square root of root 3 squared plus 1 squared, which is the root of 10. So what are we on about? Root 3 squared is not 9. Root 3 squared is 3. That's the root of 3 plus 1, which is root of 4, which is 2. B, find the cube root of Z. Oh, and the argument, sorry. The argument as well. The argument of Z. It's always helpful to think about where it is on the complex plane. Minus root 3. It's going to be back here somewhere. Plus I, it's going to be up here. Minus root 3 plus I. The argument of Z is equal to inverse tan of what the man. It's been a little while since I've done this, clearly. Root 3, that's 1. That's the angle there. No, that's the angle I want. So that is opposite over adjacent, root 3 over 1. Inverse tan of root 3 over 1, well, minus root 3 over 1, really, which is 150 degrees. So part B, find the cube root of z, which lies in the first quadrant of the Argand diagram. That's easy. If z cubed is equal to 2e to the I, well, I'm going to write this in. What would this be? 5 pi by 6. So that's 5 pi by 6. Then z is equal to the cube root of 2, e to the I, 5 pi by 18. Find the smallest possible integer n for which z to the n is a positive real number. Okay, so z, so C, z was equal to e to the, so 2e, although the 2 is not going to be important for this bit, to the 5 pi by 6 times I. And we're asked, when is that a positive real number? Z to the power of what? So z to the n is equal to that to the n, which is basically just asking, when is 5 pi over 6n equal to a multiple of 2 pi? No, not 2 pi, because if it's just want it to be real, it doesn't have to be positive. So just pi times k. So can we find a real? So the pi's obviously aren't important. So can we find a real number such that we're going to get a whole number answer here? Well, the first one is going to be n is 6. It's going to cancel it out. So when n is 6, oh no, did it say positive or not? Oh no, it does say positive. Sorry. So do you need the 2? N is 6 would give us the answer 5, which is obviously not positive, so n is 12. That's the smallest value of n. That will give us a positive real number. Okay, a bit of kinematics. Particle P moves along the x-axis such that its velocity is given by cos of t squared. Given that P is at the origin at time t equals 0, calculate the displacement of P from 0. So V is the velocity is equal to ds by dt. So I want to integrate ds by dt with respect to t. It's the same as integrating cos t squared with respect to t. And that's going to give, and I'm running from what, after 3 seconds, so 0 to 3. Now that's not something you can evaluate by hand. Cos of t squared is the calculator paper, you're not expected to. Stick it in your calculator, you get the answer 0.703 meters. And then part 2 is the total distance travelled by P in the first 3 seconds. So, because it's cos t squared, it's obviously it's oscillating in some sense, isn't it? Without having to think about too much what that might look like. Although, again, you can tap it in your calculator and find out what it looks like. Then we are basically solving the total distance is just the just given by the absolute value. Because any negative distances will get turned into positive ones. So when we evaluate the area, those will no longer get subtracted. And again, it's just a case of sticking it in your calculator, and this time pulling out the answer, 2.05 meters. This answer has to be bigger than this one, since part 2 is the total distance. Right, on part B, find the time at which the total distance travelled by P is 1 meter. So this time we don't know T. We've got to set up this equation. It's the integral from 0, so not T. Yeah, 0 to T. T is what we're trying to find. Cos u squared. Don't understand why they've used u instead of T this time. Oh, because they're trying to, T is the variable here. That's why. So they're trying to make a distinction between that T and the variable in here. So they've called it u. So cos of u squared with respect to u is equal to 1. And again, that's a case of sticking it in your calculator. Lots of calculator use on this calculator paper. Not so much on the next question though. F is of the form f of x is x plus a over bx plus c. Given that the graph of f has asymptotes at -4 and y equals -2, and at the point 2/3, 1 lies on the graph, find the values of a, b and c. So, first thing to realise is that x can't be minus c over b, because if minus c over b, if x was minus c over b, then that would give us an asymptote. Where else are we getting an asymptote? We're getting an asymptote at x equals -4. So minus c over b. If minus c over b was equal to -4, then we get an asymptote. And there's also one at y equals -2. Well, to think about where would you get your horizontal asymptote, you have to think about what happens as x gets very big, or very small, very negatively big. And what happens is f of x gets closer and closer to x over bx, or 1 over b. So therefore my other asymptote must be given by 1 over b equals -2. And from here, we can obviously solve the equation b is -1/2, and then we can use that to substitute into here to get -c equals b, well, 4b, which is 4 times -1/2, which is -2. So that's -c is -2, so c is 2. Just going to find a. I haven't used this piece of information yet, which is basically that f of 2/3 is equal to 1. So that's 2/3 plus a over bx, so b we know is -1/2, times 2/3 plus 2. That equation can be tidied up an awful lot. Let's times it by 6, top and bottom. No, let's just look at 2/3, let's just do this, is equal to -1/3 plus 2. Is that right? -1/3 plus 2, yeah, because these cancel. Let's give -1/3. So we've got 2/3 plus a is -1/3 plus 2. Take away 2/3 from both sides, I get 2 minus 1/3 minus 2/3 is A is minus is 1. No. Oh, I've made a mistake somewhere. It's here. Made a sign error. It's getting late. So that means that this is minus 2 there, it's minus 2 there, minus 2 there, it's minus 3. Question 7, another kinematics question. A ship S is 10 kilometers north of a motorboat M at 12 p.m. Ship S is 12 kilometers north of a motorboat. So that's 10 kilometers. Ship is traveling northeast. Northeast, so that's 45 degrees. Well, let's call that, what, 135 degrees. With a constant velocity of 20 kilometers an hour. The motorboat wishes to intercept the ship and it moves with a constant velocity of 30 kilometers an hour. So the motorboat is going to come and do something like that. And it's moving at 30 kilometers an hour. In a direction theta degrees east of north. In order for the interception to take place, determine the value of theta and the time at which the interception occurs. Okay, so I'm going to call these sides of the triangle 30t and 20t. So I'll be able to set up equations in t and theta using what I know. So I think the first thing to do is use some sine rule. I'll be able to set up that. Let's give this point a name as well. Let's call this point X for interception. So using sine rule, I get that Sx over theta is equal to Sm over something that's no use to me. Mx over 100 sine theta. Sine 135 degrees. So the nice thing about this is the t's are going to cancel. When I put in Sx, I get 20t. When I put in Mx, I get 30t over sine theta over sine 135. Bit of rearranging. T's cancel. That's the zeros. Sine theta over 2 is equal to sine. Should have started with it that way around, really. Equals 2/3 sine 135, which is 28.1 degrees. And then to get one of the other missing sides, 20t, 30t, doesn't really matter which, I'll do sine rule again. Um, 30t over sine 135 is equal to 10 over sine 180 minus 135 minus 28.1, that's 15063.1, 16.9 degrees. Triangle. And again, we get 30t is 3t, just t. go with t. It's sine 135 over sine 16.9 times 3, which comes out to be 0.811 hours. Times that by 60 gives you 49 minutes, which means the time of the interception was 12:49. Right, this one I put in, even though I said that vectors wouldn't come up, because it's a nice GCSE level vectors question. And it was some easy marks. Be aware, this is just talking about vectors, about lengths, not about the vectors themselves. Oops, that's not a regular hexagon. So we've got a regular hexagon, regular-ish. 0, A, B. I've got this vector A, this vector B, C, D, E. And we want to show that OC is equal to 2AB using some sort of vector method, really. Perhaps one way to do it is to show that A to B is equal to B minus A, and that O to C is equal to A. No, is equal to it's difficult to do without just assuming it's true. I mean, I don't like this question at all, because I think it's sort of trivial. But O to C, what have you got to do? You've got to you can do, it's A plus A to B is B minus A plus B to C. How do you get from B to C? Just using these vectors. The problem that I'm having is that I think if you try and use a vector approach, you sort of inherently have to assume at some point that these two vectors are the same. And if you assume those two vectors are the same, to show that one is double the other, you're kind of just going around in circles. So the actual proof that those one length is double the length of the other sort of has to resort back to some knowledge of angles. I'm making the argument that way, because any argument on vectors to prove this is true implicitly assumes that it is already true, and you can't reason like that. So I think the easiest way to do it is to say, I'm going to call that X, the triangle OAX is equilateral, since everything's 60 degrees, which implies that OX equals AX. Maybe being a bit more thorough than you'd need to be. Triangle XAB is also equilateral, which implies that AX equals AB equals OX. And by a similar argument, we can infer that XC is equal to AB. And since OC is equal to OX plus OC, plus XC, that must equal AB plus AB, which is 2AB. So yeah, I think any attempt attempt to do that vector using vectors is going to ultimately lead to circular reason that's not going to count. Find the position vectors of C, D, and E. So we're looking for OC. Well, we've just worked out that OC is double the length of AB, and since it's parallel to AB, it must be equal to 2AB. And since the position vector of OA is A and the position vector of OB is B, that's just 2B minus A. For OD, which we're asked for, the easiest way to do that is OC, which I've just worked out, plus CD. And CD is just going to be negative A, so that's 2B minus 2A minus A, which is 2B minus 3A. Should also definitely get in the habit of putting little underlines on your vectors. OE is equal to, well, I can just do that, OD plus DE. We've just worked out what OD is, 2B minus 3A. And DE is obviously minus B minus A plus A minus B, and that gives me 2B minus B is B, and minus 3A plus A is minus 2A. And the last part of section A, where I'm going to break off, is a ladder against the wall 10 meters long. Is moving, the ground rests against the vertical wall, the bottom loader is moved away from the wall at constant speed at 0.5 meters a second. So that's 0.5 there, which we'll call dx by dt. What's the relationship between that and dy by dt? And what's the relationship between this point and this point, which we'll call x? That length is x. That length is y. Well, it should be obvious from Pythagoras' theorem that x squared plus y squared equals 100. Differentiating that, we get, with respect to t, you get 2x dx by dt plus 2y dy by dt equals 0. Substitute in, we want to substitute in a value for x. We've got a value for dx by dt. We can get a value for y. Calculate the speed of descent at the top of the ladder when the ladder is 4 meters away from the wall. So this, when x is 4, we get 16 plus y squared equals 100. Y squared is 84. So y is the root of 84. Y equals the root of 84. So that is 2 root 84 times 0.5 plus, nope, that's the wrong way around, so that's y. Let's do this again, and this is why I need a break. 2 times 4 times 0.5 plus 2 times root 84 dy by dt equals 0. And so a bit of rearranging gives us that dy by dt is equal to minus 0.218 meters per second.